Welcome to Coach O's Pre-Algebra. Well, I hope you guys are having a great day or had a great day. It's the evening and I'm doing this at night. So I had to think about it a little bit. This is going to be a really short video, so you're going to have some homework to go or daily work to go along with this video. In some of you it might be a review and some of you it might be new, but there's going to be a couple things I want to review about it. Just a quick review. Let me get a pen. Just a quick review on a power, okay? So remember the base, and you have the exponent, right? The base is the number, the exponent is the exponent, and the whole thing is the power, okay? That's important because when we're talking about multiplying and dividing monomials, we're going to use a rule, and when the bases are the same base, when you're multiplying monomials or dividing monomials, then there's a certain rule that you follow, the rules of exponent. We're going to do two rules today. So when we're multiplying monomials, we have, this is the official, the mathematical accepted rule. A to the m times a to the n equals a to the m plus n. You add the exponents when the bases are the same. So down here I already did a couple. So you have x to the 5th times x to the 3rd equals x to the 5 plus 3 equals x to the 8th. No, you don't need to show that step, but you do need to show it in your notes because you need to show that that's what happens. Once you understand that, you can go straight and go x to the 8th. 2 to the 3rd times 2, well, that exponent is 1, 2 to the 1st power, so you have 2 to the 3 plus 1 or 2 to the 4th. If all it does is, if the directions simply say rewrite using exponents, simplify using exponents, then you do not have to evaluate. They want to know that the answer is 2 to the 4th. They don't want to know that it's 16. Down here you have 3 to the 0 times 3 squared. These are still the same base. And 3 to the 2 plus 0 is 3 squared. And remember, anything to the 0 power is 1, always 1. So you could say, well, I know that 3 to the 0 is 1, so it's got to be 3 squared, unless it says evaluate the power using exponents. If it tells you to evaluate using exponents, it's expecting you to use the rule. So that's pretty straightforward. When you're dividing monomials, you are going to subtract. None of these are going to come out negative exponents. We're doing negative exponents next, and I will give you a video for that because I do a little bit more than the book does. So when we're dividing monomials, we have a to the m divided by a to the n, and we subtract. If we multiply, we add. When we divide, we subtract. Inverse operations. So a to the m minus n. C to the 5th divided by c squared is c to the 5 minus 2 or c cubed. Yes, you may simply go c to the 3rd power. You know my problems on my quizzes and tests are going to be more complicated than this. The book problems are pretty straightforward, and I'm probably going to be on Monday of next week, we're going to have an assignment where you are doing more advanced problems where you're multiplying and dividing, okay? It's not going to be based. The little practice homework I've got you from the book is really simple and straightforward, and that's why you're going to do that. You're not going to do very many. I think I'm doing the odds. It'll be up next to this video. But then you have 4 to the 5th divided by 4 cubed. When it does this, you do not want to multiply this out and go to 4 to the 5th and then go 4 to the 3rd power and then divide. You want to take advantage that you're going to use the rule of exponents so that you don't do a lot of extra work to simplify this problem. Why does this work? Why do these rules work? Do you know? How many of you said because these are factors? That when you have an exponent, the base is a factor, and you're telling the exponent tells you how many times you multiply that factor. That's why this works. If I have c to the 5th, if I have a number that's c to the 5th, and it's the fact, and they have the same base, c to the 5th and c squared, and c is the same factor, it's the same number, and I have in this number, whatever it creates, I have 5 of those factors. And in this one, I have 2 of those factors. Well, when you simplify fractions, you take the greatest common, that's right, factor. So these are factors, and the exponents allow you a shortcut to simplify those. That's why this works, is because it's based on the fact of factors and greatest common factor. Okay, pretty straightforward. But you need to know why it works, right? That's why I went into this. Now this is more like you're going to see on Monday with a worksheet. So you have a string of monomials that are being multiplied together, and you have to be careful. A lot of people make mistakes here. You would say, oh, I would not make that mistake, but in a testing situation, you might. I highly recommend that you go through and you circle the ones that are the same base first. So I have x cubed and x to the 0 power. You can just add those together and get x cubed, and you've already taken care of that. Times, now you're going to have 2. Now, this is what I'm talking about. People make a mistake here because the 2 doesn't have an exponent, and they go 2 times 3 is 6 squared. You may say you would never do that, but you would be surprised. It's one of those mistakes that just sneaks up on you when you least expect it because you're not paying attention to the little details. And it's a careless mistake. You're going to know the rule, and when you're in a testing situation, you're going to rush. And sometimes, I'm just telling you, always be aware that when you have numbers thrown in there, the rule still applies. So there's a 2 here and there's a 2 here. We don't say 2 times 2 is 4 squared. We say 2 and 2 squared is 2 cubed. Then I have y, and I have y squared. So I've got y to the 4th, I get y to the 6th. Now this one I have 3 squared and 3, it's the same thing. I get 3 to the 3rd power. Now, tricky part. You have to simplify this. You can't leave it like this. And when it says evaluate the expression with this many variables and this many numbers, this many monomials, it doesn't want you to do what it did at the beginning, which is just simplify it quickly and just show the variable with the number like 2 cubed times 2 to the 2nd is 2 to the 5th. They want an answer. When it says evaluate, they want an answer. So what you're going to have to do is you're going to have to say, oh, 2 cubed is 8. And 3 cubed is 27. Oh boy. 27 times 8, 49, 56. 16 and 5 is 21. So you have to evaluate that. That's different from the first time around when I told you if it just says evaluate using exponents or simplify with the exponents. This one is going to say evaluate. And then you would have to put it in what kind of order? That's right, numerical order. And also, well, not numerical order, alphabetical order, because you've got the exponent, the variable. So x cubed and y to the 6th. That would be your final answer. This is just a quick reminder. Negative 3 squared, be careful, times 2 times negative 3 squared. These are not the same base. This is not negative 3 squared. Is it? No, it's the opposite of 3 squared. You've got to be careful with that. These you cannot combine. They are not the same base. This square is only with the 3, not the negative 3. Be very careful with that because those are the kinds of problems you'll have on Monday. So here, I can't do much, can I? No. This is going to be negative 9 times 2 times 9. Does everybody see that? Remember, that's way back. We did that early with the parentheses when the negative sign is included with the exponent and then when it's not. But don't get confused when we're doing these monomials, the rules of exponents with monomials, and that you go, oh, negative 3 and negative 3, that would be negative 3 cubed. No, it's not. Okay? So be careful with that. And then that's negative 81 times 2, which is negative 162. You would evaluate these. That's it. Pretty straightforward. I'm not going to give you any practice problems because what you're going to do is you're going to do a few problems that are already assigned for the daily work. You guys, I had celebrated my first night of Passover tonight and had our Seder virtually with my whole family all over the country, and that's pretty cool. And I hope those of you who celebrate Easter have a great weekend, and I'll see you on Monday. some of you in class. Well, I'll see you guys in class today if you watch it before you see me. Have a good one.